everyone, a very warm welcome to my presentation on the topic, the applicability of the solar-powered aquaponics mobile unit at Sharjah campus for sustainable perspective of food security. The work was done by Dr. Hassan Abdulmouti and his team and is now being presented by Ms. Ahana Fatima Alex. I once again welcome you all. Here is the outline of today's presentation. It starts with a synopsis to give you a briefing on what to expect in this paper and an overall view on this paper. Starting with the aim of this work. As we all know, the current trend in agriculture as well as aquaculture is on aquaponics, which is a combination of both. So is the research interest in aquaponics due to the enormous advantages of the system over the traditional and conventional systems. So this paper aimed at showcasing the need for an aquaponic system which is powered by solar energy so as to ensure food safety all throughout the world as well as in the UAE. Therefore, a prototype was created within the mobile learning unit at our Sharjah campus of HCT. And as I've mentioned, we have used PV system or photovoltaic system for the overall energy supply, the details of which will be elaborated in the forthcoming sessions. And with this technique or with this setup, we were able to analyze two crucial functional parameters. One is the amount of electricity which is needed by the solar panels for the LEDs as well as for the water pump sets used within the system, and how it is beneficial over the normal or conventional techniques. And second thing is we were able to determine the influence of fish farming and plant thriving on the aquaponic system's water quality and nitrification effectiveness. So we could broadly say that the study has estimated prospects of using renewable energy to run a cost-effective aquaponics framework as a sustainable food production technique. So let's see more in detail. Coming to the introduction, let's see why we need aquaponics. Why aquaponics? Why not some other system? And what is aquaponics? And what is its significance? So speaking about the need for aquaponics system, there is a huge compromise happening between the demand and the supply of food for the growing population. That is, with the increase in population, the food demand is at the rise, but the supply is scarce due to many factors, including the limited availability of land with increasing urbanization, with water consumption, or say over 70% of freshwater withdrawals goes to the agriculture sector, which makes scarcity of water also. Apart from that, conventional farming techniques as well as aquaculture techniques requires large amount of water resources as well as land resources, which in turn enhances the water and environmental pollution, which is a rising issue globally. So in short, we could say population growth and food safety issues have promoted the concept of aquaponics, which actually eliminates all these drawbacks and also addresses the UAE's and UN Sustainable Development Goals. So what is aquaponics? Aquaponics, as the term suggests, is a type of bio-integrated structure that blends aquaculture and hydroponics to create a mutually beneficial ecosystem for the growth of aquatic life and plant life. So now the waste products of the fish, which is nothing but the ammonia, is treated due to the presence of some symbiotic relationship between the plants and the nitrifying bacteria and turns it into plant nutrients such as nitrites and nitrates. So both the plants as well as the fishes are benefiting from this techniques by using a co-ecosystem. So when space and water are in short supply, aquaponics is often favored over conventional farming. By sharing a common water source, plant and fish could thrive in a hospitable setting that reduces water use significantly as well as pollution, water pollution as well as soil pollution. So same way we could see another system, a systematic diagram of aquaponics where we can see the need of filters, the air pumps, the water pumps and the tanks in which the hydroponics as well as the fishes are grown and how it works. So let's see what are the significance of aquaponics system. So we can say that first and foremost thing is that the significance is aquaculture and hydroponics reduces the dependence of resources and enhances yield. Second thing is it significantly reduces the water usage and also the water is recycled. 90% efficient than the conventional agricultural schemes, and we could strongly say that 90% water usage is less in the case of aquaponic technique. Resource reduction and efficiency by combining innovations in vertical farming, which is nothing but less effluent while utilizing less physical space than traditional agriculture. Also, it provides year-round production of crops along with improved plant growth rate. In the UAE, an economic heavily depend on imports, all of these vital issues could be addressed. That is, in UAE, it is an economy which is highly dependent on imports. So here we actually, by using aquaponics, 99% of that could be addressed. Coming about the literature review, due to the constraints of time, we have put in only few major works which we have reviewed in the design of our prototype. One being by Nasser et al., wherein they have studied the overall reduction in traditional agricultural pollution. So we incorporated that work here so as to reduce the pollution and all sorts of effluents. The second paper actually made use of some sensors, actuators, and microcontrollers in their system for the to keep tabs on the aquarium's temperature, the lighting conditions, and food supply. So that was also incorporated in our system, which gave a low maintenance and cost effective option. And the last paper which is mentioned here is on a solar powered aquaponic setup that can be controlled by an Arduino microprocessor. So that was also made use here to get the setup completely solar powered. So now, with the literature survey, we have identified certain gaps by incorporating the best techniques as well as which will be powered using solar energy. So to fulfill the or say to bridge the gaps found in the literature, we propose the following objectives. That is, it aimed at establishing a fully smart and sustainable aquaponic system at HCT Men's campus. And the vision of the work was to develop a system that can be scaled and commercialized to establish HCT as an important hub for sustainability in the UAE and the wider region. To achieve this, a working prototype was set up in our MLU, and the system used 90% water, less than conventional techniques. And to make the system fully sustainable, we designed it to operate using solar energy, which is a renewable energy. This picture on the side showcases the various steps involved in our setup, which will be again broadly shown in other pictures. Coming to the methodology that we adapted, we could say that we can classify this methodology into two sectors. One is being the aquaponic prototype system, and the next is the solar energy system installation. So first of all, we have set up the complete aquaponic system, which is very, low maintenance system due to its automatic water recirculating system. So this involved placing the water beds in which the fishes are grown and also the plant beds wherein the plants were grown. And then the waste was converted to nutrients from the plants, and in turn the plant helped filter and clean the water, which was suitable for the fish. And again, the system incorporated many factors which helped in addressing issues such as soil degradation and desertification. And other thing is that once the setup was made, the next thing was to set up the solar panels. So initially we had to calculate the energy required to work this entire setup. So that was done, and later we have installed the system. So solar energy or say PV systems were designed to operate this complete aquaponic system, and we calculated that 6 PV modules were needed for the LED lights to support the plant growth, and 13 modules were needed for the pumping system to pump or circulate the water throughout the system. The total area of the installation was 50 meters square, and all solar panels can be easily installed on the roof of the MLU, since the area of MLU was 55 meters square, which was more than the required installation area. So here is the layout of the aquaponic system that we have done in our HCT campus. So as you can see, this one is our main fish tank, and 2 is our water pump for that, and 3 is the grow bed with plants in clay ball media and plant, which is powered using an LED. 4 is again a water tank which takes the water from 3, and 5 is the vertical planting area farm, and 6 is azola, a fast growing species of aquatic fern. 7 is a floating raft bed with another set of greens. 8 is another water tank for smooth circulation of water for healthy growth of fishes and plants. Now, the P1, P2 and P3 mentioned here are the pump sets that were equipped within the system. Having said this, here is the grow bed, which is 3 as in mentioned in the layout, with plants and clay balls and ball media and plants. And here is the main tank wherein the fishes were kept. So above the main tank comes the grow bed, and here is the vertical planting area in which all the plants were grown. This figure shows the experimental grow beds, that is azola, the fast growing species, and the floating raft beds with all the green layout. So these were the experimental grow beds. So that was the entire setup, and then it was powered by solar panels. Coming to the solar PV system design, it can be classified into 2, that is solar power needed for the LED lights and the solar power for the pumping station. So now the calculation for LED lights, the LED lights were required by the mobile units as well as for the plants. Lights for the mobile units and lights for the plants. So we can see the calculations accordingly. Here we can see that solar powered calculations for LED, that is first one for the mobile unit, it required lumens to cover the mobile unit, and it was around 6,300 lumens, and 18 watt LED lights with 1,100 lumens were selected. The required lights is the total requirement divided by the selected ones, which gave us 5.7 lights. So we have opted for 8 lights, which would actually provide some extra support if in case. And the second one is the calculation for lights for the plants, which we have taken 6 LED lights with 60 watts. Therefore, the total appliance energy needed for LED lights was 18 watts, which is that of the 1,100 lumens which we have selected, into the 8 lights which are needed by the required lights, and into 8 hours, which is the number of working hours for this solar energy is needed for that 8 long hours, plus the number of 30 watt LED lights which is needed for the lights for the plants, into 6 lights into 8 hours again. So the total gave us 2,592 watt hour per day. After calculating this, we have went for the total PV panel energies per day, which is nothing but 2592, which we have just calculated into 1.3. So now determining the total energy per day required from PV panels by multiplying the total appliance energy per day, that is by a factor of 1.3. This factor actually accounts for the energy losses due to issues such as, say, shadings, the temperature, and inverter efficiencies. So assuming an average efficiency of 85%, total PV panel energy per day is calculated by multiplying the energy consumption by a factor of 1.3. So we have taken that factor, and the total energy needed per hour was 3369.6 divided by 8, which gave us 421.2 watt per hour. Again, the sizings, we have taken 6 PV modules as per the calculation. Same with the battery capacity, we found that it should be 1651.7 amp hour. And for 100, therefore for 100 amp hour rated batteries, we required 17 batteries. And the charge controller for the batteries were equivalent to 40 amps. All the specifications which we have taken for our monocrystalline PV panels for LED lights are as shown in the figure 11. The details are, more details are there in the paper as well. Coming to the pumping system, we required 3 pumps as seen in our layout, and each had 1300 watt. So the total required power was calculated to be around 46,800 watt hour per day, and the total energy needed, again multiplying by the factor 1.3. So the total PV energy for a day was found to be 6840 watt hour per day. And the total watt hour of PV panel capacity for 1 hour was found to be 7605 watt power. And the number of PV panels thus we found was, or say we have taken 14 modules. The found one was 13.7, so we rounded it to 14 modules. And the system was powered by 14 modules of 555 watt power solar panel. So hence, by all the calculations, we found that the solar power inverter size should be around 5000 watt. So our implications or our inferences on the topics can be again split into 2 systems, that is our aquaponic system as well as on our design of solar PV system. Speaking about the aquaponic system, a working aquaponic system was set up there in our MLU at our Sharjah campus, and the project has helped us to establish HCT as a center of excellence for sustainability, and further we will be exploring the possibility of establishing a program in sustainable development or an international center of sustainable research at HCT. And again, we also are aiming at promoting and encouraging sustainable agricultural practices and ideas to ensure food security in the UAE, because we have designed a system in which we are getting less amount of energy for the designed structure than few of the existing techniques. So we could say that even though it is through a it is powered using a sustainable energy source, we are using less amount of energy compared to many of the systems or existing designs. Speaking about the design of PV system, what I've mentioned just now, we are using 6 PV modules and 17 batteries for the LED lights, whereas for the pumping sets we used 14 modules and 20 batteries, which is like very less as compared to many other designs which are showcased in few of the literatures. And the area of installation for PV systems for LED lights were 3.75 meters square, which again is a significant efficiency as compared to the overall area we have used for this setup. And area of installation for the pumping system was 45 meters square. So the solar panels can be easily installed on the roof as the roof's area is 54 meters square, which is more than the required installation area in precise calculations. So now about the solar PV system, we could say that the calculations made for PV requirements bridge the energy requirements of the aquaponic system, and hence helped in achieving a sustainable ecological system using renewable energy. And this fruitful methodology actually motivated and enhanced the model design to build a large-scale aquaponic system in a broader spectrum, starting within the campus and spreading it to the city. We are actually on the process of developing the entire system. We are doing that right now. Expanding the model to more MLUs and throughout the campus now. So as a future work, we are proposing IoT, or we are working on actually IoT enabled systems. That is, say for example, we are looking for IoT enabled systems that could actually activate our pumps, the tanks and water beds using Wi-Fi enabled sensors or switches. Wi-Fi I mean, with the use of Wi-Fi, we could actually work the sensors or switches remotely. We could control it remotely. And the next one is on our layout. Our future aim is to improve or improvise our layout of the system. That is, we need to incorporate more sophisticated techniques. That is, with part of reserved solar energy to be utilized by more devices, as well as increasing the capacity of our system for more plant growth and fish growth. The third one is on the water flow rate, that is to best control of water flow rate for the whole system and to maintain a constant flow rate. The next aim will be on incorporation of hydroponics within the system. That is, as of now, it is aquaponics. That is the growth of microgreens. So we are looking into hydroponics, which helps in growing more bigger plants. And finally, to incorporate a AC system, that is designing a renewable and sustainable air conditioning system that will actually promote more of the plant growth in, environment like Dubai or say UAE, where we can certain plants that require lesser temperatures, as well as the fishes as well. I mean, the aquaculture also need lesser temperature. So we are looking at the design of such a system. So here are a few of the references that we have used. Thank you.